All right, so the first one we're going to look at is this number 21. These are your distance, time, and rate problems. And we always use the formula D equals RT, where D is the distance, R is the rate or speed, and T is the time. So the first thing we want to do is we want to make sure that all units are the same. And that basically just means that we have to convert minutes into hours. And in order to convert minutes into hours, we just take the minutes and we divide by 60, because there are 60 minutes in every hour, equals hours. Okay, and so for number 21, you actually have two pieces of this. The first piece is riding the bike 20 miles with a constant speed of 10 miles an hour. And the second piece is riding an additional 4 miles an hour, 4 miles with a constant speed of 8 miles an hour, and that's a different speed. So we have to calculate these separately and then add them together. So for the first piece, D, R, and T. Let's find that. So Bob rides his bike 20 miles. That's the distance. With a constant speed of 10 miles an hour. That's the rate. And we don't know what the time is. Okay, and so for this other piece, we'll find the distance, the rate, and the time. And we find these three things because that's what our formula uses. And so he rides 4 miles, and that's the distance, with a constant speed of 8 miles an hour, which is the speed, or the rate. And again, we don't know the time, so we need to find each of these separately, and then again, find the sum of what we end up with. So distance equals rate times time, that'll give me 20, equals 10 times t. And here I'll have 4 equals 8 times t. And so to solve for t in both situations, we're going to divide on both sides. And for this one, let's see, we're going to end up with 20 divided by 10. That is 2 hours. And 4 divided by 8, which is 0.5 hours. And so 2 plus 0.5 is going to equal 2.5 hours total. And that's for number 21. So our answer here is 2.5 hours. All right, so for number 22, we're going to do something pretty similar, and we should have room on the paper here to work this one out. So again, we're going to use that D equals RT, and I encourage you to write it down every single time until you get really good at these. So let's first make sure that our units are the same. I've got 72 miles per hour at a distance of 36 miles, so that looks good. So the distance is 36 miles. Let's see, the rate is 72 miles per hour. And I don't know what the time is, so we're just going to plug into our formula here. So 36 is equal to 72 times t. And we're going to solve for t by dividing on both sides of the equation by 72. So 36 divided by 72 is going to give me 0.5 again. And in this case, I'm done. So this is 0.5 hours. Okay, so for number 23, we'll do that in very much the same way. So again, we'll do distance, rate, and time. So the distance, we don't know because it says how far. So 240 minutes is the time, and the first thing I'm going to notice is that that's in minutes. And so I probably should convert that. So that's 240 divided by 60, so that'll give me 4 hours. So the time is 4 hours. The rate is 12 miles per hour, and we're looking for the distance. So D equals R times T. And so that's 12 times 4, which is going to give me 48. So that's 48 miles. All right, this one's really similar. This one's pretty similar. This one is similar. This one is like number 21. Has two pieces, so is this one. This one's like number 21 2 pieces. This one's like that too. This one is like number 21, 2 pieces. Do take notice though that you want to make sure, again, even though these are like number 21, you want to make sure that all your units are the same and convert any minutes to hours that you need to. And you want to make sure to use this formula because like we are looking for how much time here we're looking for what distance, and then here we're looking for time. The rest are exactly like number 22 and 23, and then they're just one piece. And as long as you're using this formula every time and you're trying to pull the D, the R, and the T out and then just plugging it into that formula, you're pretty much going to get the same result every single time, as far as you'll have an equation that you know how to solve because it's a single step equation. So I'll post a key in addition to this video, but for now I'm going to move on to a couple of these. And so for these, again, this is just the distributive property up top and factoring, and we'll focus more on the factoring ones at the bottom. And this is just a model. So I multiply 2 at x, I'll end up with 2x. And for this box, I'll multiply 2 and -4, and I'll have -8. So as a product, we write it as the length times the width. There's the product. That's two things multiplied together, the 2 and the x minus 4. And then for the sum, we just add what's in the box. So that's 2x minus 8. And so what's inside the box gives us our sum. And so as we move along, you'll have various little puzzles here. And so this one asks you to take a squared plus 4a and write what it would look like if you factored out the a. And so let's go ahead and write the sum inside. That makes it easier. And so a goes here. And so then we just need to figure out what goes here and here, which incidentally is just, if you want to do it algebraically first and you're more comfortable that way, that's fine. You just factor the a out of this, and we know that that's a plus 4, and so a must go here and 4 must go here. And so then we look at it and let's say, okay, let's make sure we're right. A times a is a squared. A times 4 is 4a. And we're all done. I'll post a key in just a few minutes. Happy studying. Send me a reminder if you need to in order to ask a question. I'll be happy to get back with you.